The last colligative property is osmotic pressure. Osmosis is the selective passage of solvent molecules through a porous membrane from a dilute solution to a more concentrated one. A semi-permeable membrane allows the passage of the solvent molecules, but blocks the passage of solute molecules. The osmotic pressure, symbol pi, is the pressure required to stop osmosis. Remember, the flow is always from the dilute to the more concentrated through a semi-permeable membrane. Pi is equal to the molarity times the gas constant times the absolute temperature. In this case, the molarity, remember, is the number of moles per liter of solution, volume in liters. Temperature must be in Kelvin, and R is the gas constant. Here's a picture of cells in an isotonic solution, meaning that the osmotic pressure is the same inside and outside of the cell, a hypotonic one which causes the cell to swell, and a hypertonic one which causes the cell to shrink or collapse. Here are some photomicrographs showing the same thing. Colligative properties of non-electrolyte solutions are summarized below: vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Colligative properties of electrolyte solutions differ. Remember that colligative properties depend upon the number of particles. For example, if we have a 10th molal sodium chloride solution, that will dissociate into a 10th molar sodium ions plus a 10th molal chloride ions. That is 2/10 molal of ions in solution. The Van Hoff factor, I, is the actual number of particles in solution after dissociation divided by the number of formula units initially dissolved in solution. For sodium chloride, it should be 2. For calcium chloride, it should be 3. For non-electrolytes, of course, it's 1. For electrolyte solutions, the colligative properties are multiplied by an I factor. So the freezing point depression is I times Kf times the molality. The boiling point elevation is I times Kb times the molality. And the osmotic pressure is equal to I times the molarity, RT. Here are Van Hoff factors, actual measure and measured. A colloid is a dispersion of particles of one substance throughout a dispersing medium of another substance. Notice the difference between a colloid and a solution. Colloid particles are much larger than solute molecules. Colloid suspension is not as homogeneous as a solution, and they exhibit the Tyndall effect, which is shown on the left and on the right through the forest. Here are examples of different types of colloids. You're familiar with many of them, such as fog or smoke, or whipped cream or mayonnaise.